You might not know much about Tethys, but you should know this. The moon called Tethys is a survivor, an icy world orbiting Saturn at 295,000 kilometers. It may appear unremarkable at first until you learn what it has endured and become amazed that it's even here at all. Take a closer look at its scarred surface, and you'll see what I mean. Not many moons house a gargantuan trench system that wraps around 3/4 of their body. A tectonic rupture so vast, it beggars belief for a world this size. And opposing it, a gigantic impact basin stares back, evidence of a collision so violent it should by all rights have blasted this moon into fragments. What did this? And how did Saturn's fifth largest moon survive the onslaught? The answers lie in its frozen icy shell. With the light of modern science, secrets long hidden about Tethys are finally coming to light. Today, join me as we delve into the history and geology of Tethys, Saturn's scarred survivor. The first recorded observation of Tethys came from the astronomer Giovanni Domenico Cassini. After arriving at the Paris Observatory, Cassini, whose name centuries later would be given to a famous space probe, identified Tethys in 1684, along with Dione, adding them to his growing list of Saturnian moons that already included Rhea and Iapetus. Following the custom of the time, these moons were initially called Sidereia Lodoicea, or the Stars of Louis, in honor of King Louis XIV. However, this name did not last. In the 19th century, John Herschel proposed a new naming convention inspired by the Titans of Greek mythology to create a stronger connection with Saturn, or Cronus, the king of the Titans. Tethys, fittingly for a water ice world, was named after a Titaness and sea goddess. And it is indeed icy. A key characteristic revealed by gravitational measurements, primarily from the Cassini spacecraft, is Tethys's remarkably low density, about 0.97 grams per cubic centimeter, or 0.97 times that of liquid water. As a result, Tethys's mass is less than 1% that of our own moon, even though it spans a third of the moon's diameter. This extremely low value strongly indicates that Tethys is composed almost entirely of water ice, with only a small amount of rocky material mixed in. It suggests Tethys likely never fully differentiated into a distinct rocky core and icy mantle. Or if it did, the core is exceptionally small. The density might also imply some degree of internal porosity, meaning the ice within might not be perfectly compacted, potentially containing voids or less dense ice structures. This composition makes Tethys a quintessential example of an outer solar system ice world. Physically, Tethys presents as a typically bright icy satellite. Its high bond albedo, reflecting around 60% of incident radiation from the sun, confirms a surface dominated by water ice. The surface is relatively free from significant amounts of darker rocky or carbonaceous contaminants seen on moons like Iapetus or Phoebe. Tethys also has an irregular shape resulting from the gravitational influences of its neighbors. Don't forget to like and subscribe for more amazing journeys through the universe. The classical sphere shape has been squashed into a triaxial ellipsoid, meaning that it has 3 axes. However, perhaps the most arresting feature on Tethys is one of its landmarks, Ithaca Chasma. This enormous canyon system dominates the moon's topography. It measures up to 2,000 kilometers long, 100 kilometers wide, and 5 kilometers deep. Now, I really want you to take a moment to grasp the size of this feature. Imagine a crack running from New York City almost to Denver, Colorado, and you start to grasp the scale relative to the moon's size. It dwarfs Earth's Grand Canyon and is proportionally one of the largest canyon systems in the entire solar system. rivaled perhaps only by Valles Marineris on Mars. The existence of such an imposing feature on a seemingly simple icy moon begs the question, how did it form? Other theories have considered links to the giant impact crater Odysseus, suggesting the shockwaves might have fractured the opposite hemisphere. However, the chasma is thought to be older than the Odysseus basin, and detailed modeling suggests the expansion freezing model provides a better fit for the observed geology. Ithaca Chasma, therefore, isn't just a spectacular sight. It's a record of Tethys's thermal history, a dramatic indicator that this now frozen world may once have undergone growing pains on a cosmic scale. Surface temperatures on Tethys are incredibly low, averaging around -187 degrees Celsius, ensuring water ice remains brittle and stable against sublimation, except over very long geological timescales. It's cold enough there that the water ice on Tethys can often act like rock. Tethys lacks any detectable atmosphere, leaving its surface directly exposed to the harsh environments of space. Micrometeoroid impacts, solar radiation, and charged particles within Saturn's magnetosphere all bombard its surface. Only not all of those micrometeoroid impacts were micro. One was large enough that it nearly shattered frozen Tethys like a bullet through a snow globe. It's time to take a look at the Odysseus crater. If Ithaca Chasma speaks to internal forces, the Odysseus crater screams of external violence. Located on Tethys's leading hemisphere, Odysseus is the moon's largest impact basin, measuring approximately 450 kilometers across. That's more than 2/5 the diameter of Tethys itself. The impact responsible for this enormous feature was thought to have occurred between 400 million and 1 billion years ago. And judging by the size of the crater compared to its moon, if Tethys had been icy and hard like it is now, there's a significant chance Tethys would have been broken into pieces. But it seems the impact occurred when Tethys's interior was still partially molten or slushy, allowing it to absorb and dissipate the impact energy more effectively than a completely solid, brittle body could have. An unlucky break. Interestingly, Odysseus is remarkably shallow for its diameter. Unlike the sharp, bowl-shaped craters we see on rocky bodies like our Moon or Mercury, Odysseus is relatively flat, its rim subdued, and its central peak complex largely collapsed. This is not how it would have looked immediately after the impact, and suggests a phenomenon known as viscous relaxation was at play. Over geological timescales, even solid ice behaves somewhat like a very thick fluid, especially when topography is significant. The immense depression created by the impact and the uplifted rim would have slowly slumped and flowed under Tethys's own gravity, gradually smoothing out the crater's profile. The degree of relaxation observed in Odysseus provides further clues about the thermal state and composition of Tethys's crust at the time of the impact and in the eons since. Which makes sense. Like a nuke suddenly detonating, such a large impact tends to release a lot of energy, and it would seem logical that not everything would remain icy. The impact likely resurfaced a significant portion of the surrounding terrain, either obliterating all the craters or smothering them with its ejecta. If you enjoyed this video, hit the like button and subscribe to support the channel and see more fascinating content. So Tethys has taken some hits over the years, both from within and without. But that's not all there is to this moon made of ice. Another notable discovery from Tethys was its unusual thermophysical properties, which amusingly tied it to a 1980s computer game character. In 2015, Cassini's composite infrared spectrometer made a series of observations of Tethys's daytime anti-Saturn hemisphere over a 9-hour time period. This produced data to confirm an anomaly that had previously been identified in 2012. That the lower latitudes of Tethys's leading hemisphere appear cooler in the day and warmer at night compared to the surroundings. This area of Tethys also appeared darker in infrared and UV color ratio maps when compared to the rest of the leading hemisphere. Funnily enough, the pattern when mapped out made the moon look like a giant Pac-Man, which gave scientists a good chuckle, and proving their sense of humor. They gave this phenomenon the same name. Still, the Pac-Man heat map on Tethys and a similar one on neighboring Mimas needed an explanation. Tethys orbits Saturn at a distance of about 295,000 kilometers, making it the fifth largest moon in the Saturnian system. Its orbital period is short, just under 1.9 Earth days, and like most major Saturnian moons, it is tidally locked. Why does this matter? Well, this gravitational interaction ensures Tethys perpetually presents the same hemisphere towards Saturn, dividing its surface into a leading hemisphere facing the direction of orbit and a trailing hemisphere. This helps keep Pac-Man facing the same direction, which also brings us to its color. The leading hemisphere facing the direction of orbit appears to be between 10 to 15% brighter than the trailing hemisphere, and its near-infrared spectrum suggests that it has more pure water ice on its surface. This pattern is generally attributed to external factors. The leading hemisphere is the side that gets exposed the most to weathering by particles from Saturn's E-ring and Enceladus's plumes. This weathering will sandblast material onto the surface of the leading hemisphere, which tends to consist of submicron-sized icy particles. Smaller water ice particles reflect more light than larger particles, therefore giving the leading hemisphere a higher albedo. The trailing hemisphere, conversely, is more heavily bombarded by energetic plasma particles trapped within Saturn's magnetosphere. This high-energy radiation can sputter surface molecules, break chemical bonds, and implant ions, processes collectively known as space weathering, which tend to darken and age icy surfaces over time. Contamination by micrometeoroids carrying darker material could also play a role. In other words, we now think that Saturn's rings are to blame for feeding Pac-Man, as the differential bombardment from E-ring particles across the moon's leading hemisphere modifies the surface. This will give certain regions a higher thermal inertia, meaning they store and release more heat effectively than their surroundings, therefore creating the observed temperature differences. It's a pretty fun finding, one that makes you realize just how much these moons are shaped by their unique interactions with Saturn's rings. Tethys may lack the atmospheric complexity of Titan, or the obvious present-day activity of Enceladus, but it is far from a boring, inert world. It is a body profoundly shaped by extreme events. Its story is writ large across its surface in the form of Ithaca Chasma and the Odysseus crater. It is also an incredible example of how worlds and moons are influenced by their wider neighborhoods. Tethys is icy, but the subtle variations in its surface texture and color hint at ongoing interactions with the Saturnian environment. Traveling around Saturn and its rings changes Tethys, and studying the two helps us better understand these dynamic interactions. Sadly, there are no new missions to Tethys currently planned. But Tethys has survived worse fates. It has been squeezed. It has been sandblasted with icy dust, and it has been struck from above with forces that could have shattered it. Tethys is a survivor. And although its crust is made of ice rather than rock, Tethys remains unbreakably resilient in the face of the universe. It has survived everything the cosmos has thrown its way so far and will surely continue to move forward with strength. Thank you for joining me on this journey of discovery. If you enjoyed the video, please like, subscribe, and share so more people can experience the wonders of the universe together with us. Leave a comment below with your thoughts or any questions you might have about the planets. I'm always happy to hear from you and reply. See you in the next adventure. Goodbye, and thank you, everyone.